good. Yeah, so what we do, 7.2. Trigonometric integrals. So we try to do the basic ones. There are a lot of complicated ones, but we only do the basic ones. But if you need to study everything, just go to the handout. Okay? It covers everything that you need to know. The trigonometric integrals. So what we're going to do, we're going to break the theories into several cases, and then we're going to go case by case. Okay. So that's what we're trying to do. First, we try to do some problems with sine and cosine, and then we try to go to tan and sec, because depending on the function, you need a different technique. Okay. So and most of them are substitution methods. So this is the extended version of substitution method. Okay. You might feel, oh no, this is just substitution. That's fine. If you feel it like that. Okay. So. Okay, so for the class, we try to learn these three types. Okay, so we try to integrate these three functions. What is the first one? Sine mx cos nx dx, and then we try to do secant mx tan nx dx, like as powers. These are powers, is that right? And third one we try to do sine mx, like you multiply times. We don't need the parentheses. We don't need the parentheses. And the cos nx. So those are the three types that we're going to learn today. We try to how to do these, and each has different methods. So let's try to go to the first case. So in case 1, we try to do this one, sine mx cos nx dx, when, so this is the special case, when mon is odd. Is odd. So if one of them is odd, things are easy. Okay, if one of them is odd, one of the powers, either cos or sine, one of the powers is odd. In that case, things are much easier. You can see that. And this is not how the book explains, but this is much easier. Okay, so what we try to do, so this problem simply becomes a substitution problem. So use substitution. So use substitution. So we use substitution. U equal, I'm going to call it like this. Use the other one. Okay, what's the other means? If one is odd, pick the other one. Okay, not the odd one, the even one. Okay, so one is, so that if both odd, it's up to you. It doesn't matter. You get the answer. You can pick one of them. So other means not the odd one, the even one. Odd. This odd. And then once you use the other one, we know that you need to find the, so we pick u, the other one, and then we calculate du, and then after just a basic substitution problem. Okay, and also we're going to use the Pythagorean identities. So in the middle, because we know that what we're trying to do, we try to express the whole function using that other function. Okay. So in that case, what you want to do, you want to use these identities. Sine squared theta equal 1 minus cosine squared theta, or cosine squared theta equal 1 minus sine squared theta. So you might want to use these. And also in some cases, like if you want to handle like large powers, we want to use the Pascal triangle also. So we might need the Pascal triangle. We know, like we discussed that in our previous class also. So we might need 1, 1, 1. Remember that? 1, 2, 1, 1, 3, 3, 1. You just add the two numbers to get this one. Okay? 1, 4, 4, 1, 4, 6, 4, 1. Like that. Okay? We need that. What is this actually? This is just the coefficient when you expand something. Like for example, a plus b squared equals to a squared plus 2ab plus b squared. See the coefficients? 1, 2, 1. That's the number. Okay? So if you remember this one is much easier. I mean, you can go to like, we go underground like 100. Okay? Maximum like 5. So it will help you. Like for example, a1, like a minus b. Let's say a minus b cubed. So those are the coefficients. 1, 3, 3, 1. That's what it says. So, okay, that's a negative sign. That means switch the sign. So we start with a3 and then 3 times, what is 3? That's 3 times 3a squared b plus 3 times the other 3. ab squared minus b3. So, you know, it might help you. So that's why. So you can use this, okay, in case you need that. Okay. So let's try to do the first problem. So just knowing these, you can do 100 problems. For example 1. Evaluate cosine cube x dx. Okay. Evaluate cosine cube x dx. Okay. So because you can rewrite this problem as cosine cube x sine 0x dx. Is that right? Sine, you put 0. So you can see that the cosines are odd power. Is that right? So what is u? U equal? What's the other function?
Sine.
It's not cosine, it's the sine. Okay, so we pick the other one. Because this is odd, so pick the other one. Okay. And then what happened? Then you can write, what is du?
Cosine.
Cosine x dx. Don't forget dx. Okay. Now, okay, so that's the starting point. So you pick the other one. So this is how we do the problem. We start with cosine cube x dx. What we're going to do, since it is an odd function, we can separate one of them. So we separate one of them, one of the cosine, because we need that. That's why we do that. Okay. So we separate one of them. So we can write cosine squared x, and we separate one of the cosine x dx. Is that right? And then, what is cosine squared x from the Pythagorean identity? It is 1 minus sine squared. And this is cosine x dx. Now you see the next step. What's the next step? This is 1 minus, what is sine? Sine means u. So this simply becomes
1 minus
u squared. What is cosine x dx? du. Now you can see that this is just a very basic substitution problem. Now this is very easy to integrate. So integrate, what do you get when you integrate? U minus u cube over 3 plus c, but you cannot leave u because it is something you introduce, so you put that back in. What is u? U equals sine x. So that means your final answer is sine x minus sine cube x over 3 plus c. So you can see that easy. Okay. So use the other function. Use the other function as the substitution. So let's try to do one more. So I might do something. I might pick something from the book. So is that clear? So pick the other function. What's the other function? Because it's a sine, cosine. So pick sine. So let's do a different one. Good. Example 2. Let's say, how about this one? Find let's say sine 5x cosine squared x dx. Sine 5x cosine squared x dx. Okay, so now sine is odd. So what is u? Cosine. The other function. Not that one, but the other one. So du equal negative
Sin x dx.
sin x dx. Okay. So let's start the problem. Sine 5x cosine squared x dx. Now what you want to do, you want to rewrite the whole equation, whole function using cosines. That's the goal. You try to rewrite everything using cosine. Okay. So this is a sine, so we need to rewrite this here using cosine. So okay, so let's try this. Okay. So what we can do, you can write this one as you can remove, because this is odd power. You can take one. You can separate one of the sine term. So you can write this as sine squared x squared. What is that? There are 4 there. Is that right? There are 4 there. And we're going to leave that cosine squared term there. And we're going to separate that one of the x term there. And why I want to do that? Once I do that, this simply becomes, in this case, negative du. So that's the goal. That's why we do that. But for that, you have to have an odd term. Okay? Odd term. So now, I'm going to start. Yeah, that's fine. We have space. Because you're going to substitute from u, so that means you cannot have this term there. So what you're going to do, this sine squared x you're going to replace by 1 minus cosine squared x. Okay, so it is 1 minus cosine squared x squared. Okay. We can leave this one because it's just u. So I'm going to leave this one there. And we can also leave this one there because this is just du. Okay. So now just expand this one using, because this case you don't need the Pascal triangle, this is just a square. But if it's a large amount like 3, 4, 5, you might need the Pascal triangle. Okay, otherwise you don't need. So it is 1 minus 2 times cosine squared x plus the square of that one becomes cosine 4x. Is that right? And then this cosine squared x. Okay, and then I'm going to rewrite this sin x here. Good. Okay, now we can put all the u's there. So you can see this is 1 minus 2 cosine x equal u, so this becomes u squared. Cosine equal u, this becomes u to the 4th. This is u squared again. And then this sin x dx is negative. I put the negative sign outside and du. Okay. So this is just so you distribute that. So once you distribute, you're gonna get u to the square minus 2 u to the 6 and u to the u to the 4 and then u to the 6 du. Just multiply by u square each term and then you integrate term by term. So you're gonna get negative u3 to the 3 minus 2 to the 5th u to the 5th plus u to the 7th over 7 plus c, and then you're gonna put that back into from sine term, not sine, cosine term. Then you get negative cosine cube x over 3 and 2 5th cosine 5x plus cosine 7x over 7 plus. This is just a basic method. Only thing can happen in a different problem is you might have to expand a lot because if you have a larger part. But for that, just use the delta Pascal triangle, and then you get the whole of it. Okay. Good. Now let's go to the second case. So the case 2, the same type of integral, sine mx cos nx dx when both, because if one of them is odd, we know how to do it. But what if like both odd, both even? But then we get stuck because we can't do this. Okay? When both m and n are even. When both m and n are even. If both m and n are even, we cannot do this. Is that right? We're going to get stuck because once you try to take one term, here you get like just cosine x. So for cosine x, you can just, you can write it using sine terms, but it's with a square root term. So those integrals are not that easy. You get square root terms, and then we don't know how to do that. Okay, so that's the problem. So you cannot do this in this. It won't be this easy. So how about something like this one, like this. So example 3. Okay, so before that, so in this case, what we try to do, let's talk about the theory part. What we do, we can use the half angle, or sometimes we call the double angle formulas. Okay, so we try to use sine square theta. Do you remember sine square theta? How you write these in the half angles? Is 1 minus cosine 2 theta over 2. Whatever you have here, you double it. For sine, it is a minus sign. For cosine, it is a plus sign. Okay, that's the only difference. Sine minus cos plus. So this is the major tool to do even problems. Because when you have an even power, you can write it like that. This is just easy to integrate. You know that. Okay? It's just easy. And so these are the other formula that you might need. So we know cos kx dx was integral 1 over k sine kx plus c. Is that right? See? So that means even though you cannot do this, you can do this because it's just a number. So it's just you divide by that. And then sine kx dx equal 1 over, that's a negative sign, negative 1 over k cosine kx plus. So we need these two. Okay? We need these two. And the Pascal also, if you have a large powers. Okay. So that's the theory, the tools that you need. You need these two and these two integrals, basic integrals. Okay. So now let's try this problem. So example 3. Evaluate 0 to pi by 2. Let's say sine squared x dx. That's how the problem looks like. 0 to pi by 2 sine squared x dx. And we know that we can do the trick that we used last time. It's not going to work. So the answer, so what we can do, we can rewrite this one. So it is 0 to pi by 2, you can put the numbers there also. Sine squared x dx. Now we use that double angle formula. Sine squared x dx equal to 1 minus cosine 2x over 2. Is that right? Just the identity. Just the identity. Now, to make things easy, you can take 1/2 out. If you do that, it is 0 to pi by 2, 1 minus cosine 2x dx. Now, this is a very easy integral. Okay. So, 1/2. What's the first one? X. What's the next one? This is a cosine. Cosine means so minus this. You can divide by that number. So it is 1/2 sine 2x plus 6. Okay, and pi over 2. Just using that identity. Okay, what the identity says, if you want to integrate cosine 2x, it is just 1 over that number sine that 2. If it is 2x, it is 2x. That's just the identity that we just had. I can show you the identity. I'm going to show you. So we can use this. So the cost is just 1 over k sine k. Okay. So if that is the case, then it is x minus this is a cosine, so the 1 is the 2, so 1/2 sine k. Okay. And let's plug in the values. So you can see that once you plug in 0, this is 0, sine 0 is 0, so this is gone, so we need to plug in only pi by 2. So it's 1/2 pi by 2 minus 1/2 sine 2 times pi by 2 means sine pi, but how much sine pi? Sine pi is 0. Sine pi is 0. So what's the answer? Pi over 4. I mean, even power, that's what we try to do. So if the other one is also even, like let's say you have a cosine 4, then you can write it like this, okay, because it's an even power. I'll show you, but I don't do the whole problem, okay. So like for example, let's say like this, whatever the numbers. So let's say you have like cosine squared x sine 4x dx, like that. I just give you just the steps, okay. So what you can do, because these are all even powers, so you have to rewrite this problem as like this. This one is fine, so you can write this one. I'm going to leave that one for the moment. And this one you can write this as sine square. Okay. Once I write it as square, now what I'm going to do? I can put the double there. Okay. So you can say this is 1 plus cosine 2x over 2, the first one. The next one is 1 minus cosine 2x over 2. And then what you can do? You can square this. So what's going to happen? You get a lot of terms. Okay? But whenever you get another square, you can use the identity again. Okay? But this is for you. I mean, it's like we can ask like very difficult question in an exam. But this is for your knowledge, for the homework, I can ask this question. Okay, so what's going to happen? Once you expand, you can see that you're going to get a square there, cosine squared 2x. Now what you can do? You use the identity again. Then it's go to 4x. Okay, is that right? So that's what you do. So you just keep doing until you're going to see a like constant term like that, okay? Like this. You remove all the, because every time you get an even power. Okay, so once you get an even power, if it's an odd power, you can do the problem as we did in the first 2 cases. If it's an even power, you're going to replace by the Pythagorean identity, the double half angle formula. Okay, so you can try this one, but rather let's try to do this one. Okay? Something manageable in this time. For example, 5. How about this one? Find cosine 4x dx. I just do the 4x, just the 4x. So just to show you the trick. Yeah. So what we will do? You can write this as cosine squared x squared. Okay, the 4 means 2 times 2, so you can write like that. Now what I'm going to do? I'm going to start here because I need more space. This cosine square, you can write this as 1 plus cosine 2x divided by 2 all thing square. Is that right? Now, you just take these numbers out because this 2 square means 4, so you can write 1/4 out just to avoid unnecessary problems. Okay? And then just go with the powers of that. So what's the powers of that? So this is 1 plus cosine 2x squared. Okay? That's what you get. So what do you get? You get 1. And you get 2 times cosine 2x. That's the middle term. What's the third term? The square of that is cosine square 2x. Is that right? Now what happened? These two are okay, you can do this. But this one, you have to use the identity again. Okay, so let's use the identity again. So what happened? 1/4 1 plus 2 times cosine 2x plus half 1 plus 1 cos 4x. Very good. Cosine 4x over just 4x because we write the 2. That will happen because it goes to the next power. So this is 2, now it's a double of that, means 4. Okay, now we can do this. Okay, so we can write this as separate integrals first. So you can write this as, you can combine these two numbers actually. So if you combine the two numbers, what do you get? You're going to get 1/4, 3 half, is that right? 3 half plus 2 cosine 4x, 1 half cosine, not 4x, 2x, 4x, and then dx. Okay, now you can integrate one by one. Okay, so 3 half plus 2 times cos 2x plus 1 half cos 4x. So let's integrate term by term. What do you get here? You're going to get, I'm going to write 1/4 outside. Okay, you're going to get 3 half x plus, it's a cosine. It's a cosine, it becomes sine. But with these two, it's going to cancel, so you're going to get sine 2x. Is that right? Plus, it's a cosine again, so you can divide by that number, so it becomes 1/8 sine 4x plus, that's the answer, it's sine. That's the answer. That's how you handle. So you can see that. So in some steps, you have to do it twice. But in the exams, like we're gonna give you a question that you can manage. Okay. For homework, it might we can ask these kind of long questions. But the whole point is like you need to learn the material so that you can do anything you want to do later. Good. Okay. So that's how you handle even powers. So let's try to go to the other types, the secant. So the case 3, we're going to do the secant. Secant mx tan nx dx. Okay. So first case is when the power of, or index power of secant is even. Secant has a even power. Secant has an even power. When secant has an even power, what we try to do, we try to take secant squared out and write the rest of the integral using tan. And why we do that? Because we know that the derivative of tan is secant squared. So that goes to the du part. Okay, that's what we try to do. So what we do, separate secant squared x term. Okay. separate secant squared x. We use u equal tan x. Okay. U equal tan x. And then we might also need to use some of the identities related to the secant and tangent. Do you remember that? What is that? Secant squared x equal to 1 plus tan squared x. And then sometimes we also write this one as tan squared x equal to secant squared x minus 1. It's the same identity, but we write it. So, yeah, let's do this one. Okay. So, example 5. Evaluate tan 6x secant 4x dx. Tan 6x secant 4x dx. And the power of tan is not really matters. You can see that it doesn't matter much with just u. You can have any power. Okay, so let's put the problem. So the answer tan 6x secant 4x dx. So what's the first step? We can separate secant squared out. So it is tan 6x secant squared x, another secant squared x dx, and this is useful. So what we can do, we can pick u as tan x, okay, u as tan x. If we u equal tan x, du equal
Secant squared x.
secant squared x dx. Secant squared x dx. That means this simply du. Now what you want to do, because this is a substitution problem, that means everything has to be in terms of tan. We can do that because this is already tan, so it's tan 6x, we can leave it. That's why it doesn't matter what power you have. But this one you need to write in terms of tan. What is secant squared? 1 plus, okay? Yeah, 1 plus tan squared x. You're going to leave this one, secant squared x dx. Now you can see that your integral becomes very simple now, because this is tan, that is u, so it is u to the 6. Is that right? This is 1 plus u squared. This is simply du. So just distribute that. Once you distribute that, what do you get? U to the 6 plus u to the 8 du. It's an easy integral. Okay, so what do you get? 17 u7 plus 19 u9 plus c. And then you're going to replace this u by tan again. So you're going to get 17 tan 7x plus 19 tan 9x plus c. Good. So that's how you handle terms with secant even powers. If secant has an odd power, we can do this. Okay, but you can do anything. It doesn't matter what you have for the tan, because it's just like that. Is that right? Just like that. Even you can have a square root term here. See, like if you have a square root term, you still get 1 plus u, so you can multiply. Like for example, you can try this. Okay, so I just give you an exercise. Why don't you try this one? Tan x square root secant 4x dx. You can see that you can try this. There's no problem. You can do this problem. Okay. So it doesn't matter what we have. So that's the benefit. But you have to have even power here. Even power. Any even power. Largest power, Pascal. Otherwise, you know what to do. Okay. Now let's see what if this is the odd power. Okay. So yeah, I might do that in a separate. You can try this. So the case 4, the secant 4x, no, secant mx equals secant mx tan nx dx. Well, what we say, we can say power of secant is odd. So odd power. Because if it's odd power, we cannot take that term out. Okay, so you can get stuck because you get a lot of square root terms and you can get stuck. So let's try to go to a problem. So in this case, most of the time, what we try to do, like if you go to theory part, what we try to do, we try to separate. Separate not secant x tan x. So we try to do the other one. Secant x tan x. So we separate secant x tan x in this case, and then try to use u equal secant x. Because if you use u equal secant x, we know that du equal secant x tan x, and you can get rid of that odd term of the secant. Okay, and then we try to rewrite the whole expression using secant. Okay, what we do? Write the integral using secant. Rewrite the integral in terms of a secant. And then we also we might need to use the identity that we used before, like we might need to use tan squared x. So we can remove tan terms using this expression tan squared x minus 1. Okay, we can do that because since secant is u, since this becomes just u squared minus 1. Those are the kind of things that we can try. Okay, because it's just problem to problem is things are different, so we can give a general rule, but those are things that you can try. So let's do a problem. Yeah, how about this one? Fine. We can say tan 5x secant maybe 7x. Yeah, 7x dx. Tan 5x secant 7x. So you can see that secant has an odd power. So what we do, we try to separate secant tan. Okay. So this is a tan 5x secant 7x dx. So we can separate secant x and tan x term. So it's become tan to the 6x tan to the 4x secant to the 6x, and then tan x secant x dx. Okay. So we can use a substitution u equal secant x tan x substitution. Oh, I'm sorry. U equal just a secant. U equal just a secant x. In that case, you will get du equal secant x tan x. So secant x tan x. So that means this part is simply du. Okay. So this term is fine because it's just a secant power, but this one you have to rewrite using in terms of secant. So we can rewrite this as how we can write this as? We can first write this as tan squared. Is that right? and then I can replace the secant by u, so the u to the 6, this one by du, just to make things easy. You can write like that. We normally don't do that, but we can do that because it takes a lot of steps. Now, this one you can write using, what is tan squared x? Tan squared x is what? Secant squared x minus 1, that means u squared minus 1. So this is just u squared minus u6 du. And then we can expand this one. Once you expand, what do you get? U to the 4 minus 2 times u to the square plus 1 times u to the 6 du. And then as we did before, just distribute that. So you're going to get u to the 10 minus 2 times u to the 8 and then u to the 6 du. These are easy integrals, so you can get u11 or 11 minus u29 u9 plus u7 over 7 plus c, and then you're going to replace all of those u terms by secant. So it is secant 11x over 11 minus 29 secant 9x plus secant 7x over 7 plus c. It's a long expression. Okay, so those are the kind of basic functions, but there are a few other cases. So let's talk about those few other cases. So is that clear? Is that clear? So what we did if we have an even power of secant, we separate secant square, okay, and then pick u as tan. If we have an odd power of secant, we try to separate secant and tan, and we try to use u as secant. Okay, so it works. Okay, but it's like always depend on the problem. But this is like basic theory for this special case. Okay, so let's talk about other functions. So you can say other formula, because there are 3. You don't like those numbers, okay? I know, a lot of numbers. Yeah. So the first one, the tan x dx. We did this one, remember? How to write tan? Tan we can write
Sin x over cosine x.
sin x over cosine x dx. But this is not really what we want. What we need for the top, you need the derivative of that. What's the derivative of that? Negative sign. So we can write the negative sin x over cosine x dx. Is that right? Good. Now what is this? This is just the log. It is just the negative ln cosine x plus c. We normally bring this negative sign here. That means it is that's a power. Is that right? It's a power out. So if this goes down, it simply becomes ln secant x plus c. Okay. That's one formula. So this is a formula. That means whenever you have a tan x dx, you can just write this ln secant x plus c. The next one, the cotangent. You can do a similar trick. This is cosine x over sin x dx, but fortunately, this is just the derivative of that. So it's just ln sin x plus c. So that's the other formula. If you integrate cotangent x dx, it is simply natural log sin x plus c. The third one, you have weird one, like how to integrate secant x dx. How to integrate secant x dx? So we do like kind of weird trick here. See what we can do. We can try to get the same format, like You have a function in the denominator. The top is the derivative of that. So we multiply by a special term. The special term is we're going to multiply by secant x plus tan x top and bottom. Because it's just one. Okay? But once you multiply the top, what do you get? Once you multiply by the top, you're gonna get secant squared plus secant x tan x. This is the just wait for it. This is the derivative of that. This is the derivative of this. So this is just this what? Natural log of the bottom function. So that means the derivative integral of the secant x dx simply equals natural log secant x plus tan x plus yeah, so let's just do one problem from these methods. So that's the other formulas, okay, that we need to know. Maybe let's do just one. I might do it on a different paper. Yeah, I need more space. So how about this? So example 7. According to my note, it is 7. Okay, so find tan 3x dx. Tan 3x dx. What we do? We can separate a tan squared term. Okay, so what we can do? So the answer tan 3x dx. We can leave one tan x there and separate tan squared x. Why is that? Because tan squared x is what? Secant squared x dx. So this is tan x secant squared x minus 1 dx from the identity. Okay. Now we can break this into two integrals. The first one is tan x secant squared x dx minus the next integral is tan x dx. This is very easy to integrate. Why? This is just the derivative of that. We know that if the derivative is there, we can treat this as just x. Is that right? Remember that? If we have the derivative right next to it, just substitution method. So you can just treat this as x. So that means this becomes tan squared x divided by 2. You're done. The first integral. What's the next one? That's the formula. What is tan? ln secant x plus c. Is that right? That's the answer. So we have 2 minutes. Okay, I'm not going to do this, but I'm going to tell you how to do. Like, for example, like if you have a secant cube x dx, for this one we had used the integration by parts. So this is the integration by part formula. Secant x secant squared x dx. See, this is dv, this is u. Okay. So this is the integration by part formula. See, I mean, it's just right after we change from tan to secant, now you can do this. This is the integration by parts. So I mean, that's the level of difficulty. So it's like kind of very difficult. Okay. So for exams, we are not gonna ask like anything really weird, but still I need some maybe like 10 minutes from the next class. So what left is this is just for you. Okay. Because if I ask this question in your